Assalamu alaikum and good evening all. It's near about 10:30, so we are here for our water chemistry class, day 12. Thank you all who encouraged me to continue that class. And today is a very open class for you all. I'm waiting for connecting you all. Once you all join, I will come on the topics. So I'm waiting for a minute to connecting you all. I'm waiting for a minute. Thank you very much. Assalamu alaikum. Thank you for connecting. Assalamu alaikum. Thank you for connecting you all. Today is our 12th class. Thank you. And we already crosses 11 classes, means 11 lecture. We have discussed many things. All the topics we discuss may be easy, may not be easy to understand. So today my objective is to allow you all to ask question, any question. Thank you, Mominal. Thank you for joining on time. Please do share with your team and the people you like to have in this class. I'm waiting to connect more people to join and help all to have a good time. Thank you, Asif Iqbal, for joining. Thank you very much. Thank you, Imran Nadim, for joining. Thank you very much. So, Mominul Islam. Thank you, Abdul Rashid. Thank you, Arif Ahmed. Ahmed Arif. Thank you very much. Please share with your all wall and watch party, link other people so that they can also connect easily, and I can have a better class. So thank you, many of you already joined. So I'm just starting. I just as mentioned in my topic today, I like to discuss that you actually want to understand. So I need your help. Please ask question. Please ask question if you have anything you like to discuss today on water chemistry. I have discussed from basic water, means how water look like and what are the impurities water have, and what are the common standard parameters that we do usually measure for understanding water, and we also very detailed analysis alkalinity. We detail analysis different parameter. We also try to understand, we also try to discuss, and later we discuss different chemistry, means application, dosing and other things. So I like to have you all engaged today. Please ask anything you like to ask, and depending on your question I will continue today's class. And today's is free for all. It's open discussion and question answer session. It can be based on past 11 classes or whatever you like to ask. You can ask anything. So I'm giving you time. You can write your comment as you can't speak. So please write on comments one by one so that I can start discussing on the topics what you want to understand. So thank you. I'm waiting and looking at the screen. What you like to understand, please write at comments. Please write at comments. Momin, you might have questions. Asif, Arif, you might have question. Imran Hassan, Nadim, thank you for joining. You might have any questions. So if Shahadat, you might have any questions. If you have any question, just write on the comment. I'd like to discuss on the question that you want to understand. So question, please, guys. Write down what you want to understand. Momin? No question? Asif, no question? Arif, no question? Shahadat, no question? Very good. It seems the things we understand, we don't understand what we should ask. Thank you. How we can find the alkalinity of water with aspect of alkali, carbonate and bicarbonate? Thank you very much. Umar Sharif Mughal, thank you very much. So I got a question from Umar Sharif Mughal. How we can find the alkalinity of water with aspect of alkali, carbonate and bicarbonate? Thank you very much. Mughal, usually I'm sure you understand what is alkalinity. Alkalinity is three ions especially combine alkalinity. One is bicarbonate, another is carbonate and another is OH. So when we want to understand alkalinity, basically we do test. We do a titration test. We use any acid, especially sulfuric acid we use for titration. Later on we might discuss how to test water parameters, but this is a test method, alkalinity test. So we can measure two kind of alkalinity using two kind of indicator. One is phenolphthalein, one is methyl orange. So first, usually we use phenolphthalein indicator, or we can use, if phenolphthalein indicator become pink, then we need to titrate it with the acid unless it is neutralized or colorless. After that, if we use methyl orange indicator, it becomes again orange, then again titrate and we get M alkalinity. So we can do test for M alkalinity, we can do test for P alkalinity. So P and M, if we consider P alkalinity and if we consider M alkalinity, so there is a table. On that table we can have the different ion. And Mr. Umar Sharif, I will put that table on your comment, my reply comment after finishing the class. And on that table, P refers to P alkalinity, M refers to M alkalinity. So if you have the data for P and M, there are 5 conditions over there. So you have to choose which condition your parameter matches. Then you can find out from the table 3 ions, like the ion you expecting, like bicarbonate, carbonate and OH. I think I give you answer. And let me see if I can find the table in my presentation, and if I can show you, that will be very good for you. I think it will take some time, so I'll show you. I'll show you later, and I will give you the on your comment, so that you can see it and you can understand very easily. Thank you very much. Next question comes from Shahadat Hussain. Please explain the effect of conductivity in cooling water. Shahadat, thank you very much for your nice question. So usually the effect of conductivity is a sum of all ions. So all ions means they conductance, or they conduct electricity, or they are carrier of electrons. So once conductivity of any system increase, First, it increases the probability of corrosion. Always conductivity increase means corrosion increase. And simultaneously, if conductivity increase means the TDS always increase. So the conductivity increase means TDS increase means the chance of scaling will high. So the TDS or conductivity increase, the chance of scaling and the corrosion will be high. Thank you very much. Thank you, Shahadat, for your question. I think I can explain it. What is the relation in TDS and conductivity in cooling tower? Thank you very much. Next question by Shahadat. The relation between TDS and conductivity is, first one, conductivity will be always higher than TDS, as explained in my earlier classes. Like for a country in Bangladesh, the total population is the conductivity and total family is the TDS. So the TDS will be at least half of conductivity, or less than half of conductivity, or more than half of conductivity, depending on the family members, depending on the family of the salt. So that usually the meter that use a relationship that we call 0.5 to 0.7. That means if we multiply 0.5 with conductivity, we will get TDS. That means TDS is equal to conductivity into 0.5 to 0.7. But this is not very unique. It can vary in different region. So if conductivity very high, like seawater or something like that, then the TDS will be also higher number, higher factor. So basically the relationship is, importantly, conductivity is higher than, always higher than TDS. It can be half or it can be 60%, 70%, 80%, something like this. Thank you very much for asking this question. Kumar Bandi, please tell polymer role in RM plant. RM plant, Kumar, I think you think it's RO plant, right? If I understand your question, it is RO plant. The polymer is always a scale inhibitor. So all kind of good quality scale inhibitor like have polymer, that polymer work as a decrystallizer, as a crystal modifier, as a crystal distortion agent. Polymer work as a dispersing agent. Polymer work as a different kind of liquid soaking agent. So most of the cases in RO, in scale inhibitor, polymer, for a good product, if the product come from a good company, it's a good formulation, always in scale inhibitor or any antiscalant there is polymer. But this polymer is variety, huge number of polymer available in the market. Depending on the company, they manufacture and they patented on different kind of polymer. There's a lot of product in the market. So polymer actually function to control scale by crystal modifying, by crystal distortion, by dispersing the precipitate minerals in the water body or any RO plant. Thank you, Kumar. Thank you for your nice question. So I think Mominul asked a question. Mominul, what you ask? Can you? I can see your question, but I saw your question. Can you write it again, please? Mumin, I missed your question. Please you all be on my page Water Chemistry Live. I can only see the comment on that page. If you write any other watch party page or any other page like my wall or my page, I can't see the comment. So I can see comment only if it is on Water Chemistry Live page. So if you watch a party or if you watch from different area, you please come back on the page and you write the comment. That comment I can only watch and I can reply accordingly. Thank you. I'm getting so many questions, so I'm waiting for more question, guys. I'm waiting for more question. So if you have any more question, you can ask. You can ask anything. Today is open. Today is your class. You can ask anything regarding water chemistry. You can ask anything. So Kumar Bandi, can I answer your question? If you're satisfied, please write yes. You understand my answer. Shahadat, you also can write, are you happy with the question answer, or you need did you understand what I try to explain? And Mr. Umar Sharif, you also can write, is it okay that I am explained for your alkalinity? Momin, thank you very much. So some people think if they use dosing pump before feed pump will be damaged by causes of corrosive chemical. Are they correct? Basically, that if I want to answer this question, then I have to think. I'm just thinking, Mominul, for your giving you answer. It can be a concern, but first, to understand what is the metallurgy for the feed pump. Usually boiler water is a corrosive fluid, wherever chemical use or chemical don't use. The purpose of using chemical, making water less aggressive. So if I take a logic, if you don't use chemical, if the pump doesn't corrode, if you use chemical, pump will corrode. It's a matter of confusion. But answer, if I say answer directly, direct answer is very difficult, but it should not be. It should not corrode the feed water pump, because chemical normally dose in boiler. It dose, probably it's far, is at a far point of at least a certain far point of feed water pump. That means this chemical first mixed with the upcoming feed water, it diluted, then contact with the feed water pump. So I think it's easily can use before feed water pump. It should not have any problem. But if the direct chemical, because sometimes it can be concentrated, the pH will be very high. Usually the boiler chemistry, most of the chemical pH will be very high. So if the high pH can corrode the feed water pump, only the high pH can corrode, then there is a little chance. But normally the chemical dose in a pipeline, and chemical dose a certain ppm. The flow of the chemical and the flow of feed water is a far differ. That means chemical diluted in the feed water and it comes as a diluted form to, or it contact with the feed pump. So it should not corrode. Thank you, Mominul. Nice question. I think please help me. Can I convince you giving my answer? Is it okay? Thank you guys. Welcome Deacon Asad. Please you can seek any question if you have on water chemistry. I think you join today first class, so no problem. If you have any question in your mind, please you can write on comments what you like to answer or get the answer. Or Arif Iqbal, thank you. If feed tank have deaerator, then is it necessary to use oxygen scavenger? Arif, thank you. Asif, thank you very much. Very important question. And the answer is yes. Even if you have deaerator, there is no deaerator that can remove 100% oxygen. Cannot possible. Never possible. So for even if you have deaerator, you have to have dose oxygen scavenger. Even if your oxygen comes ppb level, like for high pressure boiler, oxygen comes ppb level, even not in ppm level. It comes maybe 10,000 less concentrated than ppm. Still we need to use oxygen scavenger. So for Asif, thank you, nice question. Yes, even if you have deaerator, you have to use oxygen scavenger. But if you have deaerator, the dosing should be relatively lower than if you don't have deaerator with your system. Thank you very much. So Siben Shahu, how to calculate Siben, how to calculate mixed bed OBR. Sorry, I cannot see properly. Something happened here. Just mixed bed OBR. How to calculate mixed bed OBR? Pardon me, Siben Shahu. Can you explain me? Help me to understand what does mean by OBR. I need to understand your, because I maybe misunderstand what you actually meaning. And Kumar Bandi, sodium sulfate using which purpose? Sodium sulfate, I think. Thank you, Mr. Kumar Bandi. Sodium sulfate normally not used. Your formula need to be correct. I'm sure you would like to talk sodium sulfite. Yes, sodium sulfite, not sulfate. That means that the formula you write should be SO3. So sodium sulfite used as oxygen scavenger for low pressure boiler. Kumar Bandi, thank you very much. Sodium sulfite that is used for oxygen scavenger for low pressure boiler. It can use only for low pressure, and the pressure can be maximum 20 kg. You can't use above 20 kg sodium sulfite as an oxygen scavenger. Thank you very much. Siben Shahu, I actually didn't get your question. What do you mean by OBR? OBR, you please write again so that I can understand very easily. And thank you for asking. Operation between regeneration. Asif Iqbal, pardon me, please. Please help me to understand better. What does it you mean by operation between regeneration? OBR means how to calculate mixed bed OBR. OBR mean operation between regeneration. Still I don't understand. You're talking the time. I'm sorry, I'm not getting you. So guys, if you have any more question, you can ask me again. Even you can ask anything. Today is open discussion. You can ask anything. Output, yes, output between regeneration. Okay, Shiben Shahu, thank you. Output between regeneration. You mean you want to calculate how to calculate mixed bed output, how to calculate mixed bed output between regeneration. Thank you. Even this is you can easily calculate the water flow, how much water you get it from the mixed bed outlet. After you can, if you the hours, you can calculate the amount. You can calculate that depending on the flow. This is the easiest way. If you don't have flow meter, then there are a lot of other back calculation that you have to do to understand the actual output. But if you have a flow meter, it's easy. Usually the good GM plant, most of people have flow meter. Thank you very much. How to do chlorine calculation? Thank you very much, Sarun Prasad. Chlorine calculation, thank you. Basically, where you want to use the chlorine, that is the main source to do the calculation. And chlorine, practically, if you use a chlorine gas like from cylinder, so that is a different kind of chlorine. If you use the hypo, or if you use a hypo from the chloralkali plant, this is a different concentration of actual chlorine inside it. So depending on the product that contain the percentage of chlorine, you have to understand first. Then where you want to apply, so that application you must have the understanding of the load of organic, the TSS and other things. So depending on that, in your experience, you can set the dose. The practical good thing is you must do a trial. Like for a multimedia filter, before RO you want to dose, before multimedia filter for a RO you want to dose chlorine. Then what is your target chlorine residual after multimedia bed before RO filter? So maybe you can assume the ultimate free chlorine you like to maintain maybe 0.5, just for example, maybe 0.5. Then you have to do the dose at your laboratory. You may have a dose the 5 ppm if it is a pure chlorine. Maybe if it is a hypo, then you might have to dose 50 ppm. So you have to dose in lab, and you have to test the free chlorine, how much chlorine actually consumed by water inside organism or anything, or the TSS or any that can consume of chlorine, and how much free chlorine after coming at your laboratory test. So once you understand the free chlorine is 0.5 I am getting for particular ppm of the chlorinide dose, accordingly you set your dosing at plant. So this is a basically experience and practical jar test is the right way, but still it depends on the available free chlorine in the mother product. If it is hypo, you might have to dose 1 ppm to 100 ppm depending on the hypo concentration. If it is chlorine, you might have to dose 0.1 ppm to 5 ppm. It depends. Basically there is no specific formula that I can give you how much ppm for how much this, because chlorine demand is variable. If you use river water, chlorine demand is different. If you use underground water, chlorine demand will be different. If it is ammonia plant, chlorine demand will be very high. If your system has leakage, oil, grease, odor, your chlorine demand will be very high. So practically it is always advisable use lab trial. Use lab trial to do this. Thank you very much. So Prasad, I think I can I try to explain your answer. If you are happy, please comment is okay or not, or even if you have more question you can ask again. Mominul Islam, as per boiler water dosing need many chemical, but most of chemical supplier use 1 or 2. I am confused in low pressure boiler sector. Mominul correctly saying you are right, very good. Basically country like Bangladesh or like low income country, they actually not bothering for the boiler, they are compromising. How many boiler practically, Mominul, you find it's 100% clean, or even 80% clean, or even 90% clean, or even running 70% 80% efficiently? Very few. So the people are compromising, they are not dosing correct chemical, they are not dosing with proper dosing pump, they are not dosing with correct amount. So basically as a chemical supplier we also not convinced, even myself is not convinced enough for low pressure boiler treatment. So they just compete with the competitor, and even we have to do the same, we have to do the compete with the competitor, and we have to get the business. But truly there are a lot of boiler in our scope, we are treating with the 3-4 product in a boiler, and the boiler is perfectly clean and all right. And we are using in many customer for low pressure boiler pressure maybe 6 kg 8 kg 4-5 chemicals, honestly speaking. But still there is a lot of improvement opportunity. People don't use so many pumps, people use multiple chemical in a single dosing system. So that's a really reducing the chemical efficiency, and boilers are not clean at all. I'm saying again, most of the boiler having problem, either scaling or corrosion. So if you want to do perfectly, you have to do perfect chemical dosing with a perfect dosing system. Thank you very much, Mominul. It's your opportunity, you guide your people, and you can get more sale on the pump. Asif Iqbal, what is desulfurization and what's chemical use generally? Asif Iqbal, fantastic, very good question. Basically desulfurization is a process where sulfur or sulfur dioxide remove. There are a lot of power plants, they use desulfurization. If they use HFO, maybe in fuel there is a sulfur, even some gases there might be a sulfur. So sulfur reducing, there are a lot of chemical for use for sulfur reducing. Bachmann also have some chemistry, so we can discuss on later. But sulfur basically reduced to release clean gas in the environment, sometimes to reduce the corrosion of the system. So sulfur reducing especially for coal fire plant or coal fire power plant or some HFO power plant, they use sulfur reducing plant, and there are different technology. They need some mixed bed, they need some kind of fluidized bed to do some processing, and yes, they also use some chemical also. So this is a chemical process. Thank you, Mominul. Siben Shah, what will Siben Shah? There is another question. What will be typical treated water quality at mixed bed outlet? Thank you, Siben Shahu. Typically, if you say typically, the conductivity should be less than 0.1. For a mixed bed outlet, conductivity should be less than 0.1. Should be less than 0.1, and it can be better. But at least if your conductivity less than 0.1, or it's a worst case, it should be less than 0.5 is okay, acceptable. But preferably after mixed bed, the quality should be very less, so that it means your mixed bed is performing well. Thank you, Siben Shahu. Thank you very much. So guys, I'm enjoying. You can ask any question, any more question. Even today is very open. You can ask anything. You can ask anything. So guys, I talk maybe very fast. I don't know whether you can understand me clearly, or you have any feedback. You please put comment, so that future I can develop myself also. You can give any feedback, so that I can develop myself, I can develop my speaking. I am not a good English speaker, but I try to improve my English speaking. So if you have any feedback, I never mind. You can criticize me, you can give me improvement opportunity, you can write me anything. So today is your opportunity. You can seek any question, you can ask any question. Thank you, Siben Shaho. Thank you, Mominul Islam, for making this session fantastic. So guys, if you have any more question, still you can ask and we can discuss. Thank you very much. Asif, is there any resin to remove specifically silica from the water? Fantastic, Asif Iqbal, you are a very talented guy. Yes, I also will be very happy if it be, but still not, because silica is very naughty ion. In puzzle I say very naughty in the sense it's not reactive. If you see the reactivity chart, silica is very lower side, so it normally does not react with the resin. But if your hardness is very high, the interesting thing that is not available in Bangladesh but other part of the globe they use, if your hardness is very high, means your temporary hardness is very high, the people use different kind of lime softening, that is called cold lime softening or hot lime softening. So country like where hardness is very high, maybe 600, 800, 1000 or more than that area, if you use cold lime softening or hot lime softening, silica is reduced on that area, and cold lime, hot lime softening is just like and clarified. So that area silica converted in some precipitated salt and they precipitated out. But by resin is still not a good choice selectively. But RO is the option if you have high silica. So RO is the only option. You can use RO and you can reduce some part of the silica, not all, but you can reduce a good portion of the silica. So only option for removing silica we have is RO now. Thank you Asif, thank you helping me. Nice discussion. So as per today's agenda time, it's 11, so I will take only one more question. So if you have any question, please pass. This is the last question you get the opportunity to ask me today. So this is the last question. So if you want to ask any question more, please ask me. I just have one video for you all today. I like to share one video, and after that I close the call. So if you have any question, last question I will entertain. Any last question? I think you don't have. So let's enjoy the video. So first, this video is explaining how a salt dissolves in a water. You just look how water work hard. I will explain later, but you just watch. This is a bigger salt like sodium chloride coming in water, and the blue or green are the water molecules. So just look how sodium and chlorine they absorb. This is a water molecule. The red part, you see the hydrogen as a positive, the blue part is a oxygen as a negative. So this is sodium chloride, the red one is positive and chloride blue is negative. So this is sodium chloride and this is water. You see how the salt dissolve in water. It is available in internet. You just watch. I keep stopping. There is no sound here. You just see how water molecule coming and taking individual ions. How water molecule coming and taking individual ion within the group. Just carefully observe the big crystal of sodium chloride when come in a water and how it convert into a soluble salt. Soluble salt means after that you can't see the sodium chloride. Thank you guys. So the things that I got last question from Shahadat. We use zinc based chemical in cooling water. Is there any chemical to reduce corrosion effectively? Yes, zinc is one of the best chemical, and phosphate and zinc can reduce the corrosion. But the water environment, water pH and other things we have to ensure to maintain the corrosion, and we have to check the RSI, we have to check the other parameters to control the corrosion. Thank you, Liton, you just connect at the end. So today what the video we share, I like to share you in very important things that the video you watched, how water taking the minerals like sodium chloride is a highly soluble minerals. So how water dissolve as salt. So we know that water has a positive and negative ion. That means you just think your body, you just imagine your body, there is a front side and there is a back side. Think your front side is a positive ion or your back side is a negative ion. So positive attract negative and negative attract positive. So water one side positive, when any salt come in the water, the salt becomes two part. One is a positive part, one is a negative part. So water, what do the positive part of the water, positive side of the water, several molecule of positive side of the water surround the negative ion, and the negative ion hide within a group of water molecule. Similarly, the positive side of water go to the negative side of water go to a positive ion of the salt and it form a group, and the positive ion of the salt become within the group. The interesting thing is that when the water TDS increase, the number of water molecule reduce and the TDS and they make the group number of the water molecule reduce. Still they try to hide all the salt in the solution. So that's why we didn't see any ion. Once we dissolve the water dissolving water, we didn't see any ion. Like if you take a glass of water and if you put any salt, you just shake it, you can't see anything. So where the ions went, where the ion disappeared, it disappear within the group of the water. It's okay, the water can form a group and they can hide the ions. The interesting part, if I get chance, I will have a play once if I get a physically chance. It's a group. If you like to carry something from one place to another place, like water not sitting in a place as a group, water coming through all around the system, by pump, the pump rotating and pump throwing water here and there, and water as a group they just run, and as a group they hide the ions inside the water body and they run, and that is not easy. So that's why scaling happen and many things happen, and that water become tired. So that's why in cooling water treatment we discuss many things. Inshallah we will discuss many things later. So today I like to close this consensus with you all. The heating and cooling, during heating and cooling, how water become energetic, how water become active, how water become as a team. If water does not play as a team, anytime any damage can happen, huge scaling can happen. Water can't dissolve any mineral, any salt. So water work as a team. So today we also have to fight the corona as a team. We should not go out. We should work at home. We should learn as more as possible, and we should be safe. As a country role, please be safe, be at home, but don't stop learning. So thank you very much today. Inshallah, see you tomorrow. And today I request you all, what are the topics you like to learn, so we can continue for next class. I can choose, but still I am waiting for your opinion. You please choose the topics so that we can discuss for next class or next class. So you please keep commenting. I am requesting you, you please share this to your different friends, colleague on page, so that people can understand. And once you get I get all of your feedback, the topic selected, and I will discuss for tomorrow. So thank you very much. I took 5 minutes more today. So I hope you all enjoy it. If you have any feedback, any question, pass on comments. And that's all for today. Good night. Assalamu alaikum. And সবাই ভালো থাকেন। Assalamu alaikum. Take care. Bye bye.